Hello, so it's the first time I'm doing this. I'm just gonna record me implementing a feature and see if you like it or not. Let's see how this goes. So this feature I'm gonna do is implementing enum in Slint. So this is one of that has many hearts, so that's why I'm gonna take this feature, and it also should be really easy, and maybe we're gonna do that into maybe 1 hour or something. Let's see. So first thing is to make a test. So we already have tests, and I'm gonna just take one. For example, here's the test for struct, and this is I'm just gonna rename it. I'm just create a new file, also save as enums. So it's in types, so just then so then the test should just have an enum. So let's just take this enum, for example. Up. And then export. Well, let's not have it export at first. Export test case. It's a component. Let's just use the new syntax here. Component property foo dot bar. So we want something like this, right? And test foo. Let's take the first. Let's take blah. Foo equal foo dot blah. So we'll get to this later. First, let's try just to parse this. So now if I'm only using one screen there for the recording, but I'm gonna do go run Slint viewer, and it's gonna be running the test case enums types enums. This is a new file. It's compiling, and in the meantime I'm gonna go to the parser. So the first step is gonna be to try to parse this. So I'm gonna go in the parser, and in the parser we have all the grammar here is explained with this this macro, the declare syntax. It's like a macro which is implemented there, but just create nodes and stuff, so it's easier to work with. But in the end, what we want to have enum declaration. It's gonna be something like this. We'll just do that as a comment. Like this. Enum foo. Let's do this as well. Blue. So this is gonna be a declared identifier, and then blah blue is just gonna be tokens. So we only declare nodes. So there's like a difference between nodes and token. It's using this row and crate, and syntax. This is the enum syntax scan. So it's a bit difficult to explain anything, but so those are nodes, and there's also tokens. But let's go directly to the parser, the parser that parses the document. And when we parse a document, I want to add it. So this is like a test. I can do enum foo hello, something like this, as it's a document. So this is just a test. So the test when I do so here we get proper enum, proper error, but we don't want to have an enum. But now I'm gonna run the test. Cargo test Slint compiler. So it's gonna be the Slint compiler. That's I Slint compiler stands for internal. It's all our crates are like this, and this is not great. Okay. What's the error? I made a mistake while declaring my macro. Aha, I missed this. Okay, let's try again. I need to unblock this thing. I will just do like this. So I have both windows at the same time. Okay, so I was expecting an error. Yes, we have one error. It's probably the document 6 because of course we don't parse this. Let's parse this. So if we have the so it's the contextual keyword enum. At this point, we're going to parse an enum declaration. And we'll add here something like this parse enum declaration. I'm also adjusting a bit the thing and let's go there, and it's gonna be similar to parse struct declaration. So I'll just copy paste the parse struct declaration and call that parse enum declaration. So it's gonna result in an enum declaration. So that's for the test. This thing the test just gonna take all those lines and test them separately. So I want to support empty enum. I want to or do I want to support empty enum? I guess well, makes sense. So and an enum with only one element, and an enum with a few elements. Just some basic tests here for the parsing. So we should only be called here if we are coming from if we already picked the enum. So we're starting a node. It's an enum declaration. We're consuming the enum keyword. Then we expect an identifier. So we start. I declare an identifier node, and here this P is a node, and when this node goes out of scope, it just ends the node. So that's so it just has one identifier in it. Then this was for the old syntax, but we don't have old syntax for enums, so let's just ignore this. And then this the type object is this part here, but let's go there. So this was parsing this. I'm gonna just take this. Do we want to have anonymous enums? So we have anonymous struct, but I don't think we want anonymous enum. Maybe later. So that's why it's a different function. But here I'm just gonna not do this. I want to have left braces, and then as long as I do not have air braces, I just want to have an identifier. That's it. And then maybe a comma. If I don't have a comma, I'm done, and then I expect the right brace. So that should be it. Now we run the compiler test. There is a bunch of error. I return false. So this is not an enum. Okay, so parse document still failed. enum foo enum aha, yes, so because we said that document and the document node didn't specify that it could have enum declaration in it, so we said that it can have enum declaration in it. And yep, so the parser tests are passing, and now let's look at our viewer. I will do with auto reload, and then we should have, well, it will just work. I mean, just show something because now we have an enum. But if I have nothing, it's gonna also work. Testing, no component found. Sometimes it works, sometimes not. That is a strange thing to say. Depending on how many. Okay, well, I don't know, maybe some irrelevant failure here. Yeah. So what I'm now going to do is to be able to do this. So somehow we need to register that the enums are part of the type system. So because now, of course, this is gonna parse, but it's gonna say unknown type foo because yeah, we parsed it, but we didn't do anything with it. So this is in the so-called object tree, I think, which we just convert the document to that we pass, and we generate data structure for the document. So basically what we have here, we have types, and types can be one of all of those things. It can be a struct, it can also be an enumerations, with enumeration being it has a name, a set of value, and a default value. The default value is always the first value. I think that's how it is. So the thing is that we have like built-in value, built-in enums. The built-in enums are declared there with this macro. This is some kind of macro which declares for each enum something, and it will then create those data structure, register those types in the type system, and also create equivalent structure in Rust for the runtime. Now in the object tree, so we looked at when we have a struct declaration, process struct. Yeah, because the struct declaration can be either exported or not exported. So right now I'm just gonna add quickly the support for that in document. If we have export, parse export, and then we can have struct, and we can also have enum. Parse enum declaration. So I'll just add it here as an example of what's allowed. Export enum. So I just yeah. And in the object tree, we process struct if we have a struct declaration. If we have an enum declaration, we just process enum. And also in the export list, struct declaration, enum declaration. And process struct is here just this. So we're just gonna copy paste that. It's gonna be similar. Process enum. We want here an enum declaration. Let's ignore the rest attribute for now. We can do that later. We'll think about this later. Type struct from node. So create a type object. So this is all right. No, it used to be called object, but now it's called struct. So I'm gonna do this to fix the doc as I go through it. And it's still called an object type. But then when we refactor, that's being fixed. Why not add the same here? That's actually too. I think we don't need this because this is used as well for the anonymous enum, but we don't have any anonymous enum, so we can just process it here. So we're just gonna create a enum for this. First, what's going to be? We're copy pasting this. Okay, we'll cover process enum. So name I will first get the name. So that's the declared identifier. That's an option. There should be one, otherwise let's return an option here. I mean this option of nothing. Then I can just do like this. So many errors. Some. Okay, better. So then I want to go to the children. Children with token, sorry. Filter and filter, so that's like this token kind I just want all the identifier. I just want all the identifier tokens which are inside of this. Syntax node. Kind. What does it return? Syntax kind. Syntax kind identifier. And then I'm gonna map that and I'm gonna just parse identifier text of this. Text. wonder if I should just unwrap, because the parser should have make sure that this is valid. Or if I just do filter map. And there we have it. We can collect this, and I can create an enum. So that's not the fields, it's the value. Let enum equal enumeration. It's like gonna be type enumeration. It takes a RC. So let's go there. So it's an enumeration. So that enumeration. I'm just gonna import this and then fill struct field. Okay. Name values. Oh, that seems okay. Let's say new en, and that's about it. Then I can what is that green and this red. Identifier text. It takes a syntax node. Child text identifier. Oh, that's exact. No, but that's not what it is. I just need to know. That only is if there is one identifier, but here there are several. So then, parser normalize identifier of end text. Mismatch types. What does this return? A string. So it should work. Let's call it TI. It's a type of enumeration. So we insert that into the local registry, and then inner struct. We can call that inner enums. Oh, we can keep it in struct. I think we just have to maybe rename that inner types, because it can know. Or what is this even used for? It's in the document. Well, I don't think we need that for now. So I'm going back to inner struct, and I will just not add this in there. I think this is enough already to get my little thing pass. There's a bunch of errors, so this can ignore. This we can ignore. There. Identifier, normalize identifier returns a string, not an option anymore. So it's just bad. Should do something about this. Mismatch type. Collect. str, will that work? No. Yeah, this is this syntax text from row 1. I have maybe syntax text. What do we have there? Slice display to string. But I think I can even do it's T. I want T text. T as token. What does this do? Child text as token. That's yeah, it's gonna be always a token. So unwrap text like this. It's gonna be always a token because it's all checked for identifier, and then collect. I shouldn't wrap that in a sum. Yep, the Rust type system. Okay. Now I'm trying to view my thing, and still a bunch of error. Process enum. We return an option, but so let's not return an option there. Let's just unwrap this. It cannot be. The parser should have make sure that this is not. No, the parser, there could still be an empty name, so. Well, yeah. Let's name as there we already have errors because okay. Can I not return? This does not need to be mute. Yeah, it was mute there before because inner struct I see. Thankfully we don't push to the same vector. Unknown type foo, so that did not help, despite we said local registry insert type insert. T2 string, and we have an enum. We have an enum with a type. Enumeration type to string. Maybe we add the enum. Yeah, we add the enum. Oh, this is a bit. I don't know if we want that. I mean, it's cool to have the enum, but I can also remove it, or I can do something else. But Then I need to insert type with name, the type, and then the name. We have it there. And then clone. Let's see the new. Oh, it's the same. Clone. There, I don't need to clone even, and name. Okay, let's try to run it again. So I'm just running the viewer, and this should normally, hopefully, compile. And that's it. We already have our little example here that compiles. So this is of course still the old LSP, so that's why this is still underlined, but now we have that, and we can even have that, and we can even have let's say default. I want more than that, probably. Panicked. A non-enum. Ah, okay. A non-enum. We'll have a look at that later. Let's have a look at that now. Dynamic components 101. Aha, so of course here enumeration. So that is the thing where we go through all enums and yep, so if we want to create an enum, what is an enum? An enum is just an integer, so we're just gonna store that. So that's for the interpreter, right? And for the interpreter, we're just gonna store that as an integer. That seems like a good idea. So it's any other name which is not part of the ones we know about, we're then gonna store that as an integer. U32, U size. Cannot have so many more than, yeah, it's U32 will work. Okay, so there's probably gonna be more errors there. Dynamic component 1385. So this is hard. This is the interpreter, and it does a lot of funny things. And why does this unwrap? Set value, and I know why it's unwrap. It's probably unwrapping because it's not the right type. So set returns a result, and that's the property info, and it will try to convert some kind of enum I see. So back here, when I said it was a U32, that would work, but I can also make it even simpler and say it's a value. It should be a U32, but if I say it's a value, then it will store the enum property in memory as a value, and that of course converts to and from value. So and I think in value can also be an enum. Can it? Yep, enumeration value. It's really inefficient to be stored as toString, and yeah, fix me consider representing that with a number. I will think about that later. And yes, we have our example runs now. So we want to that and default equal, so we should make sure that the default is blee because it's the first one, so we just don't specify one. No component font again. I don't know what this non-component font is. I will need to debug this, but not now. And so now I can run the interpreter test. Just run with type stuff, so because it's in type, so I'm filtering type. And so this will test that this property is true. And that works. So that's it, we have enum and Slint, but what we do not have yet is the representation of them in Rust and C++. What I want to do is to export this. This is also, I think, gonna work because we made sure that export parse. And what we want to do is to write some Rust code here where we're gonna say get foo equal, there should be an enum foo that is created. So question is, do we want that? And so it's put this. So it didn't really test if it was. No, it fails actually. Test fails. Okay. Default value void. Aha. That is interesting. And also it converted to this. For example, what if I have 42? That should not compile, right? But yeah, cannot convert float to enum foo. And if I have int foo.blah, that should also not compile. I should write test for the two, but so this should also not compile. And foo blah, that should compile. That should compile, yep, because it's implicitly in scope, but in string of course not. Now the question is, the default thing we can ignore. Can we? I mean, we need to fix this, but thinking that the way to fix this would be to. It's in the interpreter. value for type enumeration. So if it's an enumeration, we should have a proper default for the type. So I don't know why it chose to create an invalid default when running the test. Value void. For example, if I create a structure with an int and what do we have? Text. I wish this would. Maybe I do this. It's gonna. Yeah. Text overflow. Let's try that. Text overflow. I wonder what would be the default for that. Cannot convert enum foo to text overflow. Okay, so that was well, we don't know. We don't know. I'm gonna make the text fail, so then it's gonna show the value of default here. False. So because of the parser error here, I did not understand the rest of the text. So for that it worked. But for foo, it didn't work. It created a void value. Let's see how the values are initialized. In the dynamic component, property, my theory is that it is not initialized because it is not. But if I create a structure, then this is gonna probably create a structure. Let's see. Yes. Enum. Haha. Yeah. Yeah, because of course. Okay. So one of the problem here is that in the documents, in the parser, we should really have here one or several enum value and enum value can be anything. I mean, it's enum value is just the value is identifier. Because the enum is the first keyword, and we don't want that. Let's have a special note for the value in the enum. In the enum structure, then we can expect an identifier. Right. Yeah, there must be an identifier. You know, if it's not a brace, it must be an identifier. So that node syntax kind enum value. And this is gonna fail again. I mean, then it's gonna have, it says blah is no longer there, because now in the object tree where we wanted to, when we process the enum, here we need to have, then now I don't want the token anymore, I just want the nodes which are the enum value, and I have a special thing in there. It's already an enum declaration, so then there's this enum value iterator that is automatically constructed. Then I can map the enum value with parser identifier text of t. Let's call that v, it's a value after all. V v, and then mismatch, because this could filter map. Collect. Okay, and now the default value was blee, which is what we want. But that's in abstract. It's not the default value when it's not in abstract, because for some reason in the dynamic component default for some properties are generated at value for which a default constructed value must be initialized. And we're also gonna do that for type enumeration. So we should not do that for built-in types. I mean, ideally we should store the thing really as an int. So it still fails because here we do that, but if we now check that the default is foo-blee, if we run this test, it fails. Yeah, I just wanted to have foo here. Okay, now we have the test that works. What else do we need? I think what else we need is to generate Rust structure for it so that this would compile. So we want to be able to set it to full blue, for example, and what else do we need to test? Well, the test need to pass, so instance get test. We need to do that. So the question is whether we want to have foo-blah or foo-blah with an uppercase. I think the issue we were discussing about that, and we were considering to change to camel case. So we probably want to convert to camel case, and probably the same in C++. But I think the video is already long enough now. We already have declared now an enum which we can use in the interpreter. So yeah, let's stop the video for now, and I will continue the rest without recording, and hopefully make a PR for that. Okay, bye.